Welcome to this video about Kerberos. After watching this video, you will be able to describe Kerberos and its components, outline the fundamental steps involved in Kerberos protocol's flow, explain the benefits of Kerberos in domain-based authentication systems. Imagine logging into online services securely, even on risky Wi-Fi. Kerberos, a Massachusetts Institute of Technology or MIT invention, makes this possible. It serves as a secure means for exchanging service requests over insecure networks like the Internet. Using cryptographic techniques and trusted third-party mediator, it ensures the authentication of client-server interactions and user identities. From Microsoft Windows to Apple OS, Linux, and even FreeBSD, Kerberos plays a vital role in online security. Initially proprietary, Kerberos is now open source through the Kerberos Consortium. Entities employing Kerberos, including users, machines, and various services, depend on the Kerberos Distribution Center, or KDC, for essential operations. It plays two key roles: user authentication and ticket issuance. When users attempt to access a service, they first need to authenticate with the KDC. Upon successful authentication, the KDC issues two encrypted tickets, one for the user and one for the requested service. These tickets serve as temporary credentials that verify the user's identity to the service and allow secure communication. Kerberos leverages symmetric key cryptography to safeguard data packets during authentication and communication. This method uses a shared secret key to encrypt and decrypt information, ensuring only authorized parties can access the data. Let us explore the main elements of a standard Kerberos protocol, along with their tasks. Client represents the user initiating service requests. Hosting server provides the requested service to the user. Authentication server, or AS, authenticates the client and issues ticket granting ticket, or TGT, upon authentication. Ticket granting server, or TGS, operates as an application server that issues tickets for accessing services. Key Distribution Center, or KDC, is a combined system comprising both the AS and the TGS, which is central to the Kerberos protocol's function. The Kerberos protocol's flow relies on three secret keys: the client or user hash, the TGS secret key, and the service server secret key. The fundamental steps of the protocol are as follows. The client initiates the process by requesting a TGT from the AS. This request includes the client's identifier. The request is then forwarded to the KDC. The KDC validates the user's credentials, allowing for the creation of an encrypted session key along with the TGT. The AS verifies the client's credentials and generates a session key, or SK1, encrypted with the client's secret key. The TGT containing relevant information about the client and SK1 encrypts the TGS secret key. The client receives the encrypted message from the KDC and uses its secret key to decrypt the message. This process retrieves the TGT and the encrypted SK1. With the TGT acquired, the client proceeds to request a service ticket from the service server by presenting both the authenticator and TGT to the TGS. The TGS decrypts the received TGT using its secret key to extract SK1 and authenticates the process by decrypting the authenticator. The TGS ensures the validity of the client's credentials and verifies the active status of the TGT through timestamp verification. Assuming successful authentication and a valid TGT, the TGS generates another session key, or SK2, for secure communication between the client and the service server. Next, TGS constructs a service ticket containing the client's information and SK2. Then, it encrypts this ticket with the service server's secret key for added security. Finally, the TGS sends the service ticket along with SK2, encrypted with the previously retrieved SK1, back to the client. The client decrypts the service ticket using SK1, extracting SK2, and constructs a new authenticator encrypted with SK2. This authenticator includes the client's ID, network address, and timestamp, which are then transmitted along with the service ticket to the targeted server. Concluding the Kerberos protocol, the target server decrypts the service ticket to extract SK2 using its secret key. It then decrypts the authenticator and verifies its authenticity by matching the client's network address and ID from both the ticket and the authenticator. Upon successful validation, the server sends a confirmation message to the client, signifying mutual authentication. Now that you know the functioning of Kerberos protocol, let's explore KDC. The KDC plays a central role in domain-based Kerberos authentication. It acts as a trusted third party, seamlessly collaborating with other security services residing on the domain controller. Crucially, KDC leverages the comprehensive Active Directory domain services database for its security account management. Kerberos offers the following benefits in domain-based authentication systems. Firstly, it facilitates delegated authentication, allowing Windows services to access resources on behalf of clients, enhancing service delivery across diverse environments. Secondly, it enables single sign-on or SSO, simplifying access to authorized resources by eliminating repeated credential prompts. Microsoft's version of Kerberos, Kerberos v5, offers interoperability. This means it follows standards set by the Internet Engineering Task Force, or IETF, allowing it to work well with other networks using Kerberos. Compared to older methods like NTLM, Kerberos uses renewable session tickets, reducing server authentication overhead and promoting efficient authentication. Lastly, Kerberos ensures mutual authentication, enhancing network security by allowing both parties to securely validate each other's identity. In this video, you learn that Kerberos is an authentication protocol used across insecure networks like the Internet to securely exchange service requests between trusted entities. KDC performs two essential operations: user authentication and ticket issuance. Kerberos leverages a system of 3 secret keys: client or user hash, TGS secret key, and service server secret key. The protocol involves authentication request initiation, credential verification, message decryption for session keys, and mutual authentication for secure communication. Kerberos offers a number of benefits in domain-based authentication systems.